Hello students, this is week number 7 and two topics we are going to study in this week. The topic number 1 is how to draw the graph for logarithmic functions, and number 2, what is the use, practical application, clear practical application of exponential and logarithmic functions that we are going to use. Okay, but before that, there is one very important question that I should solve in the previous week, but no problem. So I am explaining this question, and this is a combination of exponential and logarithmic function. This is example given in your book 2.6.5 over page 36. This is a different type of question. You must learn it. 2 power x minus 4 is equal to 3 power x. You need to find the value of x. What happened? This is an exponential question. So generally how we are solving these questions, we are making this base and this base same. And then by the using of property a power x is equal to a power y. So this implies x is equal to y. But here this condition, this theorem we cannot use. Why? Because 2 and 3 both are prime numbers. So we cannot change 2 into 3 or 3 into 2. So if such a condition exists, such a condition arises when we cannot change these bases into a same number, then what we do? We take logarithm both the sides. Taking logarithm both sides means write log of 2 power x minus 4 is equal to log of 3 power x. And if you remember, there was a property log of a power x equal x log a. This was the property. So this x minus 4 will move to starting x minus 4 log 2 equals x log 3. Okay, so this is divide by log 2. I'm choosing different method than book because this is easy. So dividing by log 2, it is x log 3 upon log 2, and this log 2 cancelled. So how much we are getting? X minus 4 is equal to x. What is the value of log 3? If you will calculate with the calculator, it is 0.4771, and the value of log 2 is 0.3010. Clear? So if you will divide it, so how much you will get? X minus 4 is equal to, let me divide because I do not know what is the answer of division. 0.4771 divide 0.3010. It is 1.585. How much it is? 1.585 x. Now this is simple linear equation in x. So x minus 1.585 x is equal to minus 4 will be raised to this side. It will be plus 4. Okay. So if you subtract it, you will get 0.585 x equal 4 with negative sign here because this is 1 into x. This is 1.5 into x. So negative number. Divide by 0.585 x both the sides. 0.585 x 4 upon minus 0.585. This cancelled. Oh no, not x, we are dividing only number. So x is equal to, now divide 4 divide 0.585. How much? 6.84 you can say. It is negative 6.837. This is the answer. Clear? So how this problem is different from other equations we have solved in the previous video. I think 8 or 9 examples we have finished, clear, but in none of the example we have this type of condition, clear, where we can have different bases. Generally we are making bases same, but here it is not possible. Because not possible, so what we are doing, we are taking logarithm both the sides, and this is the best example. Why logarithm we are studying? We are studying to minimize our calculation, to make the calculations easy. Clear? So many calculations we do, complex calculation means difficult calculation with the help of logarithm. So this is one of the example to make the easy solution. Okay, so this was the example I need to explain you. Now we will focus on the graphs of logarithmic function. Graph of logarithmic function. And the graph of logarithmic functions are very easy. It is not difficult. It is easier than exponential function. Okay, let us choose one question we are going to take with base 10. Another question we will take with the base other than 10. So that we can learn how to transform the table of different base. Okay, so draw the graph of y equals to log x. Log x means log x and base 10. Okay, so like exponential function, first we are going to make the table. And my dear friends, here the approach is different. If you remember, okay, I will tell you. If you remember, in exponential we were taking value -2, -1.5, -1.5, 0, okay, 0.5, 1, 1.5 and 2. These values we were taking, but here we are not going to take these values. What values we are going to take? Here the approach is little different. And what approach we are going to use? Let us look. If you see log 1, first y, here any value we are going to put that gives us log 1. Why log 1? Because it is 0. This is the second value always we take. So x is equal to 1 if we are taking, we are getting 0. So you need to search a value of x for which we get y is equal to 0. This is the first value. You will take one value less than this. Here, if you remember the definition of log, then I told you x always greater than 0. X cannot be negative. So because x cannot be negative, so we cannot take less than 0. So one value we will take 0.5. First you choose this value, then take 0.5. Now take 5, 10, 15, 20 and 25 like this one. In book only 3 values they have taken, 5, 10, 15, 20. So what the value will be? Log 0.5, log 5, log 10, log 15, log 20 and log 25. These values please fix in your mind, but this value is always changing. Why? Because if question we are choosing some different x here, so this value will not remain same. So you need to check a value for which the function value is 0. One value will be take less than and then class. Okay, so it is now, sorry, what we need to do, we need to take calculator. Okay, so we are going to take it is 0.5 and log. So it is minus 0.3, minus 0.3. Okay, what is log 5? 0.698. So we can call it 0.7. And log 10 base 10 is 1, because if you remember, I told you if we are taking log of a number with same base as the number, the value is 1 always. So log 10 base 10 is 1. Log 15, it is 1.17. So it is 1.2. And if you calculate the values, all values will be like this one. If you calculate, all values will be like this one. So the first mission is to form the table. And after forming table, now the solution is simple. It is x, it is this one y, and here we will take, let us take 5, 10, 15, 20 and 25 will be in this way, and here we will take 1 and here we will take -1. So if you see at 1 is equal to 0, it is 1 here. If it is 5, so it is 1. So the value is 0. 0.5 will be like here. Here it is -0.3. So the point is here. 5 it is 0.7, almost here. 10 it is 1. 15 it is 1.1. 20 it is 1.2. So if you join all these values, how you will get the graph? You will get the graph like this one. This is, just join these values. Like this one. Clear? Mark these points. This is 20, 1.3. This is 15, 1.2. This is 10, 1. This is 5, 0.7. And this is 1, 0. And this is 0.5, -0.3. These are the values. This is the graph. That's all. So again, one thing I want to explain. We need to search a point where it is crossing x-axis, means where we are getting this value 0. Because the moment you will get this point, then one value you need to take that gives you a negative output. Clear? Negative output. So because the graph is starting with negative side of y. So always how the graph of the log x looks like this one. So you need to search one value here and one value here. Here 0, here negative. This you need to remember. This you need to focus. Okay. So we will take another example. And in this example, the same question we are going to take. Only I am choosing x plus 1 here with base 10. No problem. Clear? So how we are going to do? It is graph is almost same. Look, what is the difference? X, y. So this. No problem. How much it is? Okay. If you see here, it is log x plus 1. If I put x is equal to 1, it will be log 2. It is not 0. But if I put x is equal to 0, how much it is? It is log 0 plus 1. Clear? Log 0 plus 1 is how much? It is log 1, and log 1 is 0. So now you need to take x is equal to 0 here. At x is equal to 0, the value of this is log 1, that means 0. Understand? If you see in previous question, it was at 1 because only x was there. But here in this question, it is at x is equal to 0. So you need to take one value here less than -0.5. So whatever value you are taking here, just subtract 0.5. So 0 minus 0.5, it is -0.5. Now take 5, 10, 15, 20 and 25. So it is not difficult. Clear? Because when you are putting x is equal to, just look here, -0.5. So I told you this should be positive. Look, it is log -0.5 plus 1. And it is log -0.5 plus 1 is log 0.5. The same like previous question, minus 0.3. Clear? So if you see now it is 5 plus 1 6, so log 6, it is 0.77, almost 0.8. This is log 10. Log 10 means it will be 11, log 11, it is almost 1. Rest will be, if you will calculate 1 point, it will be 1.2, almost 1.3, 1.4, like this one. So the graph is not changed, graph is almost same. Clear? But what is the change here? This is x, this is y. Here the x was 0. So x is 0, the graph is 0. So the graph will be here. If I am taking negative 0.5, so here is negative. So the graph will start here. Previous the graph was starting here. Now the graph is starting here. Clear? So if you see this is the limit. What is the limit? X is equal to -1. Okay. So if somebody asks you what is the domain is on x-axis. So the domain here is, previously what was the domain? X greater than equal to 0. 0 was not there. X is greater than 0 only. Clear? Now x greater than 1. This is the domain here. Domain of this question. Why change? Because here is x plus 1. Range there is no impact. Range is same. Range is negative side as well as positive side. So R. If it is log x, if you remember log x, what was the domain? R plus. But here the domain is not R plus. Here it is R plus less than 1, more less than 1. So x is greater than, here if you see, it is not greater than 1. It is x greater than -1. Because it is starting here. X greater than -1. Because of what? X plus 1. So the x can take values greater than -1. So the domain is greater than -1. So this is the change if we are taking x plus 1. Okay. So the value changes as per the x, means function changes. Okay. Now let us take one more example, and that is the last example, example number 3. Y is equal to log x, and let us take base 5. If you are taking base 5, what is the change in this question? Because base 5 we cannot calculate with the logarithmic table or from the calculator. So how we are going to do? We need to change the base of logarithm. So it is log x upon log 5. Now this is log x. What is log 5? Just calculate it. It is 0.69. That means almost we can say it is 0.7. Okay. So the table is same to same. Whatever we make in a log x. Now see what is the difference. X. It is 1 because log 1 is, it is log 1 upon 0.7. 0. It is 0.5. Log 0.5 upon 0.7. So what is log 0.5? If you remember, it was a negative term. Clear? And divide by 0.7. So how much it is? Minus 0.43. So it will be minus 0.4, the value of y, and then 5, 10, 15, 20 and 25. So if you remember log 5 upon 0.7, so every value we are dividing by 0.7 because we change the base. So because of base change, the every value is divided by the 0.7, log 25 upon 0.7. So what was the value of log 5? Okay, let us calculate again. Log 5 and divide it by 0.7. So how much? It is 0.99, almost 1. Okay, log 10, it is 1 divided by 0.7, 1.4. Log 15 divided by 0.7, 1.68. That means we can say 1.7. Log 20 divided by 0.7, 1.85. We can say 1.9. And log 25 divided by 0.7. Oh, that is 1.99. 25 and divided by 0.7. 1.99. So it is almost 2. So the graph is same, only the values are little higher. Why little higher? Because you are dividing by a number less than 1. So if you draw the graph, you can draw the graph. Now I am not going to mark these points. You can mark automatically. So I want to tell you one thing. If the graph, look, if the graph of log x was this one with base 10, the same graph of log x with base 5 is this one. This is log x base 10. This is log x base 5. So what is the difference? The values are little higher. The values are little higher. Okay. So this thing you need to remember. The moment base going to reduce, the values are getting higher. This is you need to remember. Okay. So thank you very much for the graphs of logarithmic function. If you feel any doubt, please write to me in chat box. Thank you.